So in sets, let's talk about Venn diagram, okay, and how to arrive at various formulas using Venn diagram. This is set A and this is set B. What is A intersection B? Common between A and B is just this portion. What is A union B? A union B is this whole shaded portion of A and B together. So this is A intersection B. The intersection is written like this. Okay, and it's the word here in English is and. A and B. This is A union B. The union is referred to as or. Say A or B, it means union. And at least one also refers to union. So please understand, or is also union, at least one is also union. The union is written as A union B, and this is shaded portion, and A intersection B is A and B. Okay, so I'll teach you a formula for A union B. When I say n of A union B, this is A and this is B. This is n of A, this whole thing, plus n of B. So while doing that, I'm adding this twice, right? When I'm circling the one, when circling this, there's this portion. When I'm circling the green color also, again this portion is coming twice. So then therefore, I have to remove that one. So it's n of A plus n of B, which is the purple color portion, plus green color portion, minus n of A intersection B. So that's what is n of A union B formula. Okay, so that's number one. Next is, supposing they ask A only. The people who are drinking tea and coffee, the question is about people drinking tea only or A only. Then it's n of A, which is this whole circle, yeah, minus n of A intersection B. So what is the formula? So it's n of A minus n of A intersection B. What is the meaning of B only? B only is just this portion, which is n of B, again minus this whole thing, minus n of B minus n of A intersection B. So plus n of B minus n of A intersection B. So only exactly one. Either they drink tea or they drink only one. They should drink only one, not both. It's not A or B, it's only A and only B. Only A and only B. Only A, only B refers to a combination of both of this, which is n of A plus n of B minus 2 times n of A intersection B. See the way they've arrived at this formula. This is for only A plus only B. Okay, or we can say exactly one. The other word is exactly one. Refers to only A plus only B, which is n of A minus n of A intersection B plus n of B minus n of A intersection B, which is n of A plus n of B minus 2 times n of A intersection B. Okay, so that's about exactly one. This means at least one. At least one means union. Okay, so I hope you understand the meaning of at least one, exactly one. Okay, and A and B is A intersection B. Okay, so now coming back to a Venn diagram which has got A, B and C. Got A, B and C. Supposing in this they ask you exactly two. Exactly two. That refers to exactly two refers to this area, which is this red color portion, where A and B, two subjects are coming in, two things are coming in. B and C, exactly two. I'll do one more color for you. This is A and C. This means exactly two. The exactly two, for this I'm going to derive a formula. Okay, so well, let's take this one. This whole thing. What is this whole thing? This whole thing is n of a, minus you're removing okay, sorry, exactly 2. Take this part, okay? Take this part. What is this? It's n of a intersection b. And you have to remove the central part here, central part. Because this is a intersection b intersection c, just remove it. Minus n of a intersection b intersection c. So thus you got this red color portion. The red color part in here is this half part, which is n of a intersection b, which is the whole thing, minus n of a intersection b intersection c. Similarly, let's do the green part here, this one, which is n of b intersection c minus n of a intersection b intersection c. Then the purple color, which is n of a intersection c minus n of a intersection b intersection c. These three, when you add up, will give you exactly 2. Exactly 2, which is n of a intersection b plus n of b intersection c plus n of a intersection c. Yeah, minus 3 times n of a intersection b intersection c can stay as the formula for exactly 2. Okay, so let's go to exactly 1. Exactly 1. Exactly 1 means just this part, right? Just this part. Exactly A. Let's do exactly A. Exactly 1 means exactly exactly A, exactly B, exactly C. All of them getting added up. Let's do exactly A. Let's shade it in different color. This is what you want, which is the whole circle minus this part A intersection B part. In addition, you have to subtract this also, right? So let's write it in red color. It's n of a minus n of a intersection b minus, you got to remove this part. This part, what is this part? It's an intersection between, open the bracket, right, n of a intersection c minus the central part have to be removed, because when I put a intersection c, it refers to this whole thing, right? And I want only this part, so we subtract n of a intersection b intersection c. Open the bracket and now write. So thus exactly A is n of A minus n of A intersection B minus n of A intersection C plus n of A intersection B intersection C. So this is exactly A. So what will be exactly B? I don't have to really do it again, because n of A n of B minus n of A intersection B is there. So write B intersection C minus n of C. When you write A, you intersected with B and C. When you write B, intersect with C and A. Plus n of A intersection B intersection C. Even without looking at the diagram, I am able to fill it. So now exactly C will be n of C minus n of C intersection A minus n of C intersection B. Correct? Plus n of A intersection B intersection C. So if you write like this, even with, this is the method, the red color is the method, but I don't have to really analyze the method, because I'm just in the place of A, I'm writing A, B and C, intersecting A with B, intersecting A with C. So it's intersecting B with C and A. What is the option you have? You don't have any other option, right? So exactly 1 means you have to add all this, which is n of A plus n of B plus n of C minus, you see this and this is getting added, 2 times n of A intersection B minus 2 times n of B intersection C minus 2 times n of C intersection A, AB, BC, CA, plus these are getting added 3 times n of A intersection B intersection C. Okay, so that's that. This is exactly 1. Exactly 1 of A, B and C. But if they are specifically asking you only A, or exactly A, only A, then you should know that formula, which is n of A minus n of A intersection B, and the process, you remove this whole portion, but you still left with this part, which is minus n of, what is this, is A intersection C, A intersection C minus n of A intersection B intersection C. You should know, because you may have to apply this formula if they ask A only. We did a sum in the class where they had asked only Hindi or something like that, Hindi only. In that case, you need this formula. You can also memorize it if you want, but you can also learn it by understanding. It's up to you. It's completely up to you. Then they'll ask you for this formula, n of A union B union C, where this is acting like A and this is acting like a B. And n of A union B, what is the formula for n of A union B? You know it's n of A plus n of B minus n of A intersection B, where what is A? A here in this sum is A union B plus n of B is just C here according to this question, because you're considering this as A and this as B. Okay, minus n of A, which is A union B, intersection B, which is C. This is like a distributive property is what we are going to use. N of A union B itself, is n of A plus n of B minus n of A intersection B plus n of C. And this, I'm going to use distributive property, where I'm going to distribute it as A intersection C union A B intersection C. The union comes in the sentence. It's called distributive property. You should know A union B intersection C is like A intersection C union B intersection C. This union comes at the center. Okay, using that property. Now this is like again n of A union B. Where A itself is A union C, B itself is intersection C. So what's the formula? N of A, union's formula. So you're going to apply the union's formula, n of A, which is A intersection C, plus n of B, which is B intersection C, minus n of A intersection C intersection B intersection C, which is A intersection B. N of A plus n of B minus n of A intersection B. In the place of A and B, I have different values. I'm substituting. This is nothing but minus n of A intersection C plus n of B intersection C minus, there I used distributive property, previous one. I used distributive property, and here we're going to use associative property, where you see A intersection, this is like A intersection C, intersection B intersection C is like A intersection B intersection C. Now open the bracket and bring all this down. It's n of A plus n of B minus plus n of C. Let's write this first. And then write this minus n of A intersection B minus n of A intersection C minus n of B intersection C plus n of A intersection B intersection C. This derivation is very important. You should memorize all these formulas. Let me sum it up. N of A union B union C formula, you can memorize it as n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C is the formula for n of A union B union C, which I've shown it, I've derived and shown it. The derivation is also important. The next formula that I want is only A or only one refers to n of A. Only one supposed to n of A plus n of B plus n of C minus 2 times n of A intersection B minus 2 times n of B intersection C minus 2 times n of C intersection A plus 3 times n of A intersection B intersection C. This only one's formula. Where is only one's formula? We wrote it here. Can you see how I derived only exactly A, exactly B, or only A, only B? You should also know only A's formula. Apart from that, this is exactly 1, which is only A plus only A plus only B plus only C. But if they are specifically going to ask you only A, then you should know how to derive it. It's n of A minus n of A intersection B, where you're removing this, but you're still not removed it, which is this A, this C, minus n of A intersection C minus n of A intersection B intersection C, which is n of A minus n of A intersection B minus n of A intersection C plus n of A intersection B intersection C. If only you can recall this formula for n of A only, then B only, C only. Basically, you're subtracting intersection of A with B, A with C, and adding N of A intersection B intersection C. Similarly, B only means N of B. Its intersection with B intersection C and B intersections with A should be avoided, plus N of A intersection B intersection C. So easy. Okay, so I hope you're clear. Please try some sums that I'm sending as a homework. Become confident with these kind of sums. The word at least means union. At most means nothing also. Okay, there can be sums with universal set. This is universal set, and there can be A, B, and C. Okay, some people are drinking tea, coffee, and Horlicks. There can be people who are drinking none of the total people are 200. 30 are drinking tea, 40 are drinking coffee, Horlicks is drunk by 15 or something like that. There may be people who are not drinking any of this. Is universal set minus N of A union, B union, C. We did sums like this if you remember. Okay, just make sure you're thorough with these formulas and try the sums.